Hello everybody. Let us try to understand a very important function which is available in programming languages, and this function is known as actually arctan twice of y comma x. Now we have to this function is used to give us the angle theta. Now theta is the angle between the positive x-axis and the vector x comma y. We want to find this angle, so we need to use this function to find out this angle. What should have been there is that the theta should have been calculated from arctan of y comma x without this 2. Now because we all know that tangent theta is y by x, so theta will be tan inverse of y by x. In usual cases, we know this relationship of getting theta, but there are two or three problems associated with calculating theta with this tangent function. So in this lecture we will try to understand the problems with calculating theta using arctan function, and how those problems will be removed using arctan twice of y comma x. So that is basically this lecture is all about. So let us try to understand the concepts here. So the function a tan 2 y comma x or arctan 2 y comma x is used to convert from Cartesian coordinates x comma y to polar coordinates r comma theta. Basically we want r, we know, basically we want to calculate theta to put the point exactly using the polar coordinates. Now a tan twice of y comma x actually is the argument of the complex number x plus iota y. So if there is a complex number x plus iota y is the height in the y direction, and x is the distance from the origin to the projection of the point onto the x-axis. So basically, what is theta? We can say that it is the argument of the complex number x plus iota y. Now this function a tan twice of y comma x actually will return a single value, which is theta value, and this theta value will range between minus pi open interval to pi closed interval for some radius r. Now this is the radius r for a circle. This point x comma y lies on the circumference of that circle. In that case, x is actually r cos theta and y is equal to r sin theta. These are normal trigonometric relation, and our radius is given by under root of x square plus y square. Now let us try to understand what are the problems with this function arctan y by x without this factor 2. Now, but why there is a problem? Because this function holds only for x greater than 0. When x is less than 0, that means it is on the other side of the y-axis. When x is negative, the angle theta is pointing in the opposite direction. So if this is theta, angle in the opposite direction will be angle with negative x-axis will point in the opposite direction with the addition of or subtraction of pi in angle theta. Then we will get the angle in the opposite direction. Theta is pointing in the opposite direction of the correct angle, and a value of pi must be added or subtracted from theta to put the coordinates x, y in the correct quadrant. So let me just show with this diagram if this is if this is angle theta 1, if it will be put in the opposite direction, it will be pi plus theta. Now again, this theta 1 is the angle when we move anti-clockwise from the positive x-axis towards this vector. This is when we move in the clockwise direction, we get the negative of the angle. I will talk about this issue maybe in few moments, but let us try to understand the problems with tangent function first, arctangent function first. So the first problem comes when x is less than 0. In that case, this requires in which quadrant, whether we have to add pi or we have to subtract pi, we must know, we must have the knowledge of the signs of x and y separately. Now if we are using this tangent function, in the first quadrant y is also positive, x is also positive, and we will get a value theta, no problem. But in the third quadrant, y is negative, x is negative, both are negative values. So this division, when we do this division, we lose the information about the signs of y and x. In that case, we will get a wrong angle, because anti-clockwise angle between x-axis and to the vector. So 1 comma 1 will give me 45 degrees, and minus 1 comma minus 1 will also give me 45 degrees. So this tangent function will not give me the correct angle in the third quadrant. Rather, when it is when x is less than 0. And there is a second problem also. What is the second problem? The angle between x-axis and the vectors 0 comma y. In this case, what happens? There is a divide by 0 type of situation. It requires division by 0 in terms of the standard arctan function, whose range, and standard arctan function will give me values of theta between minus pi by 2 and sorry, here I have to put plus pi by 2. So it can be, so in this case, if I use arctan2 function, the arctan2 function will be modified in this way, so that it takes care of all the situation, whether x is negative or positive, or whether y is negative or positive. So the modified arctan function is, when x is greater than 0, the normal arctan function works. When x is less than 0, but y is greater than or equal to 0, in that case, I'm talking about the third quadrant. So in this case, it has to be plus pi. When x is less than 0 and y is also less than 0, that means I'm talking about the the second case is for the second quadrant. This case is for second quadrant. This case is for the third quadrant. And when x is 0, y is greater than 0, it will be equal to plus pi by 2. And when x is 0, y is less than 0, it is minus pi by 2. For x is equal to 0, it is an undefined function. That's how the arctan2 function will give me the values of theta using these different options depending on the signs of x and y. Now, the same expression, the same arctan2 function can also be expressed in this form. Let me explain this function, that how we reach to this variant of arctan2 function. Now, just to briefly point out that what is the purpose of arctan2 y comma x, often written as arctan2, computes the angle theta between positive x-axis and the point x plus iota y. It gives the direction of the vector x comma y from the origin. So why we use arctan2 instead of arctan y by x? We would have two problems, as I just explained. One is the division by 0, and the second problem is the ambiguity of the quadrant. Since arctan y by x only returns the values between minus pi by 2 and pi by 2, arctan2 solves both by taking both signs x and y. So if we use arctan y by x only, so it will, because the range of tangent function, tan inverse function, is minus pi by 2 to plus pi by 2. That means it does not tell us the values of theta between the second and the third quadrant. In that case, we will have to solve this issue using arctan2 y comma x function. Right? This function arctan2, when we the function return, it will return me angles of theta between minus pi to pi. So let us see how we can try to explain this problem. So let us take a little breath, and we will see that how this problem of arctan y comma x is solved using arctan2 twice of y comma x. Now arctan2 y comma x is what? It is an angle. What angle? Basically, it is the argument of this complex number x plus iota y. That means it is giving me tan inverse of this complex number. Now, arguments of a complex number, basically that is what this function will give me. Now argument of a complex number is angle theta as shown below. So this is so let us start from angle theta 1, right? This is the argument of the complex number y and x, and this is how we will get theta 1. Now this theta 1 is the this theta 1 particularly I am talking about is the angle between the positive x-axis and the line connecting origin and the complex number. So this is the vector that is connecting between origin and this point. So this is angle theta 1 I am talking about when we move anti-clockwise from positive x-axis to this vector. So that is what this angle theta 1 is, which is the argument of the complex number. Now in the first quadrant, x and y both are positive. Theta is positive going anti-clockwise, whereas if we go clockwise, in the clockwise direction, we will get here x is positive but y is negative. So in this case also we will get theta 2 in this using the same function arctan of minus, because y is minus, x is positive, we will get the function theta 2, right? The angle theta 2. So whenever x is positive, we can use the same formula of arctan. We can use this same formula when x is positive. In quadrant 1, the argument will be given by arctan y by x, and in quadrant 4 it will be negative of this function, which is arctan minus y by x, as I have just explained here. So we can get theta 1 and theta 2 using the same function of using tangent arctan y comma x function. But the problem, as I have explained previously also, the problem starts when x is negative. So particularly I am talking about angles theta 3 and theta 4. Now theta 3 is greater than pi by 2 because it lies in the second quadrant, but positive, as theta 3 is traced going anti-clockwise. Now this theta 3 is traced anti-clockwise in this direction, so therefore this angle is positive. Whereas theta 4, now let us look at theta 4. Theta 4 is the angle between the x-axis and this vector but going clockwise, so therefore this is a negative angle. So theta 4 is greater than pi by 2 but negative, as theta 4 is traced going clockwise. Therefore the argument will be calculated as follows. Either we have to add pi or we have to subtract pi to get the theta value. So positive if y is positive and negative if y is negative. That's how we will calculate this function. That's how we will calculate the angle theta using arctan y by x. Now with the addition of pi or subtraction of pi based on this criteria of the sine of y, right? Now this problem, now let us try to understand this problem of arctan function also, in which the range of this function is from minus pi by 2, because it will give values between minus pi by 2 and plus pi by 2. So how can we solve this problem? When we work with the argument of a complex number, we want tangent theta. So, but why we want to solve this problem? Why this is a problem? Because when we are trying to find out the argument of a complex number, we want values of theta between minus pi and pi. But the range of this arctan function is minus pi by 2, pi by 2. So therefore, we have to extend this range to minus pi to pi, right? So in this case, we are, instead of considering theta, let us consider theta by 2. So we will consider an angle theta by 2 like this, as I have shown here. Let us try to understand how this will further solve the problem. Now this is the complex number, and this is my theta, which is the angle between positive x-axis and this vector theta. So I have to take theta by 2. Now this angle, which is the angle between x-axis and it's not the origin, rather it is the point on the circumference of the circle at the intersection point of positive x-axis and the circumference. Now this is a well-known the trigonometric relationship that this angle has to be theta by 2. So this is theta by 2. This angle is between x-axis and the vector, this modified vector between the point and the point on the circumference. Point on the circumference, point on the intersection of the circumference and the x-axis. And this is basically radius. Going from origin to this distance is under root of x square plus y square, but it is in the other direction. Here it is in the negative direction. So this distance, this Euclidean distance between the origin and this point will be minus of under root of x square plus y square. That's how we will define the coordinate value at this point. And this whole distance between this point and this point will be x plus under root of x plus y square, because how do we calculate, using the coordinate geometry, how do we calculate the distance between the 2 points? It has to be this point minus this point. So therefore it is like this. So the factor that we get with the horizontal value is x plus under root of x square plus y square. So therefore my tangent theta by 2 will be equal to y over x plus under root of x square plus y square. So we will use this function to calculate the argument or theta value. And in the other case, if this point lies in the second quadrant, so again the same, this is the right angle triangle, this is angle theta, this angle will be theta by 2. Now this point is with x coordinate x, the x will be the coordinate here, and this is minus under now the distance between the two is again x plus under root of x. So this function again comes, that solves the problem in the second quadrant, which is tangent theta of y over x plus under root of x square plus y square, right? When it is in the third quadrant, or when it is in the fourth quadrant or the third quadrant, so this function, in this case only the value of y will be changed, either minus y or plus y, but the same function will give me the value of theta, right? So that's why if you see the second, let me just show here, yes, that's why this arc tangent 2 of y comma x is giving the values of theta. I have explained two ways. One is this way where I am getting the values of theta using the tangent twice of y comma x function, and this is another solution of this tangent 2 y comma x function, which the explanation for this is given here. This is the explanation when we have modified the angle theta to theta by 2, right? So all in all, we have to ultimately get the values of theta, which is the argument of the complex number x plus iota y. We cannot use the tangent function as such because of the two problems. One is the problem of the sines of x and y, the other is the problem of divide by 0 problem. So in this case, we will use the programming languages will use arctan twice of y comma x function to get the values of theta, which are actually the argument of the complex number. So this is an important function which is to be understood. Thank you.